Hey everyone, today's lesson, solving systems by elimination. This is lesson 4-3. So notice that this is already the third, and by the way, final method for solving systems. We first learned about the method using graphing, then the method by substitution, and now the method of elimination. So our driving question is, well, when is it best to use this method, the method of elimination? So first of all, what it means. To eliminate means to get rid of. So the method of elimination means that we're going to solve the system by completely eliminating or getting rid of one variable. That way we can solve for the remaining variable. So it is best to use the elimination method when one term of an equation is very similar to another term, but an opposite sign. So when two terms almost look the same, we think, hey, I could just get rid of both of those because they're the same thing. That is when it's best. And I think you'll be able to recognize that once you see a couple of examples. So like I was talking about a little while ago, we want terms that are almost identical except for their sign. So it would be nice if one was positive and one was negative. So in this example, I have 2x plus 5y equals 17, 6x minus 5y equals negative 9. Notice that we have a positive 5y and a negative 5y. They are identical except for their signs. That's what I want to see. So if I have that, so once we identify that, we can add the two equations together. We've never had to add equations, but we're going to do that. So when we add the 5y and negative 5y, well, they cancel each other out, so they just go away. We don't even see them there anymore. The 2x and 6x together make 8x. And then 17 minus 9 is 8. Of course, we can finish the problem by dividing by 8. So I see that x equals 1. So just like with the method of substitution, once you find one of the answers, you can solve for the other answer by plugging it into the other equation. So in this case, if I go back to, I could use one of the equations. It doesn't matter which one. So I use the first one, 2. Instead of x, I put 1 plus 5y equals 17. Well, 2 times 1 is 2. I can subtract 2 from each side, and I get 5y equals 15. Divide by 5 to get y equals 3. So 1, 3 is a solution. And you could always double check by plugging into the equations, or you could even check on your calculator now that I've shown you how to find the intersection when you're graphing. So we are going to do another example, but sometimes we have terms that are completely identical, even with the same sign. And we don't want that. We want one of the signs to be positive and one negative. So we can just change a sign as long as we change all of the signs of that equation. So here, I originally had 15y, but I wanted one of them to be negative 15y. I went ahead and changed the bottom. I could have changed the top one. So I changed every single term in this problem. Negative 21 became positive 21. Positive 15 became negative 15. And positive 51 became, negative 51 became positive 51. Now I have what I want of positive 15y and negative 15y. So again, I could eliminate that variable completely. I'm left with 19x. I got that from negative 2 plus 21 equals 19. That's negative 32 plus 51. How can I get x alone? Divide by 19 on both sides. So x equals 1. And then, of course, like I mentioned before, we substitute in the value for x into one of the equations, so that way we can solve for y. So I did that here, add 2 on both sides, divide by 15, y equals negative 2. So 1, negative 2 is the solution. But what if no two terms even seem similar? What if they don't even have the same number up front? Well, we must multiply one or even both of the equations to make them that way. We want them to be similar. So how can we make them that way? So we're actually going to go back to example number 1. It's technically your third example, but it's the same as the first example. But this time we're going to solve for y by eliminating x. Before we solved for y by plugging in the answer we got for x. This time I'm actually going to eliminate x. So I am not going for the obvious route that we already did. I want to make that clear. I'm now solving a different way. Well, 2x and 6x. I know that if I can multiply 2 by 3, then I'd get 6. But they'd both be positive 6, and I want one to be negative. So I'm going to multiply that entire line by negative 3. Because if I multiply 2x by negative 3, I get negative 6x, and that's what I wanted. I wanted them to be the same number, different signs. But of course, if I have to do it to the first one, I have to do it to everything in that equation. So negative 3 times 5y is negative 15y. And negative 3 times 17 is negative 51. Now I can continue with what I did before, eliminating one variable, solving for the rest. I get negative 20y equals negative 60. Divide by negative 20 to get y equals 3. Notice that we received the same answer as when we had done it the first time. I'm not going to go through the process of finding x because we already found that in example number 1. So let's continue. So this time we're going to try another one. We may have to alter both equations instead of just altering one of the equations. So here we have 3x plus 2y equals 1 and 4x plus 3y equals negative 2. There's not one that's easy to, there are not any two terms that already look very similar. I can't multiply 3 by anything to reach 4x, so that's not going to work. And I can't multiply 2 by anything to reach 3y. So I'm going to have to alter both equations. We have some options here. So please try and follow along. Take it slowly. Pause if you need to. Re-watch this portion if you need to, because this is something that you're going to have to do in class. Okay. So I could first try eliminating the y's. I'm sorry, I'm doing the x's first. So I kind of switched the numbers. I'm going to multiply the top equation by 4. That'll make 12x. I'm going to multiply the bottom equation by negative 3 because that will make negative 12x. And remember, that's the goal, for them to be the same number but different signs. In case you're wondering, I didn't have to make the 3 negative. I could have had it be a positive 3 as long as I did negative 4. So you just, whatever numbers you choose and whichever ones you choose to be the positive and negative, just make sure that at the end of the day, you're going to have the same number but two different signs, which I was able to do that. So remember, when you multiply, you'll have to multiply the entire equation. So in the top one, 4 times 3x made 12x. 4 times 2y made 8y. And 4 times 1 made 4. In the bottom equation, negative 3 times 4x made negative 12x. Negative 3 times 3y made negative 9x. And negative 3 times negative 2 made a positive 6. Now that we've created our goal, x variable could be eliminated and we can solve for y. Now, I'm not going to actually finish this problem because I want to talk about what the other option would have been. So instead, I could have tried getting rid of y first. I would use the numbers in front of y, but switch them. So on the top I'm using 3 and the bottom I'm using 2. And I had to make one of them negative. I just chose for it to be the bottom one, but it could have been either one. When I multiply those, I get 3 times 3x is 9x. 3 times 2y is 6y. And 3 times 1 is 3. And the bottom equation, negative 2 times 4x is negative 8x. Negative 2 times 3y is negative 6y. And negative 2 times negative 2 is 4. I reached my goal because one of them was a positive 6y, the other one was a negative 6y. And then I could eliminate the y variable in order to solve for x. So both of those are options. I do want you to pick one of these options, or maybe both, and solve for x and y. Try it out on your own. It's like a challenge problem. And I am telling you the answers. The answers is 7, negative 10, meaning you should get that x equals 7 and y equals negative 10. But remember, I want you to actually try working it out to make sure that you reach that solution on your own. We have one more example problem. So example number 4, I have 2x plus 6y equals 10, x plus 3y equals 9. So I want to eliminate, let's say, x. So I'm going to multiply the bottom equation by 2. And not only 2, but negative 2, because I want to make it a negative 2x so that it will cancel with 2x. So when I do that, I get negative 2x minus 6y equals negative 18. And then when I add those two together, well, everything cancels out. The x's cancel, the y's cancel, and the numbers at the end canceled. So whenever we end up with just zeros, that means that those two equations were actually the same. That again means overlapping lines. One is right on top of the other, so there's infinitely many solutions. And our final example, number 5. In this one, I already had very nicely a negative x and a positive x. So I canceled those two out. I had a positive 2y and a negative 2y. So those also canceled out. So I have nothing left on the left, as in 0, nothing at all. But on the right side of the equal sign, I had 10 minus 8, which is 2. Well, 0 can't be equal to 2. That's impossible. They're two different numbers, two different values. So this time, since I ended up with 0 equals 2, not just like 0 equals 0, then it's no solution. So let's recap as I always do. So first you have to identify, or sometimes create it yourself, a term from each equation with the same coefficient but different signs. By the way, the word coefficient means the number in front of the variable. So same number, different signs. Then, step 2, eliminate one of the variables to solve for the other. And step 3, you can either repeat this process again for the other variable or use substitution to find that second variable. Except for, there's a little asterisk, the special cases as shown above where we have infinitely many solutions or no solution at all. Make sure you bring in your notes for tomorrow. We are going to be working on this type of solving.